Hello everyone, I welcome you all to the part 2 of Euclid's geometry, and we have already seen what the Euclid says about the definitions and what is its history. Also we have seen the geometry history. Today we are going to start with Euclid's axioms and postulates. So it will be from the first part, so let's just start and see what are the postulates. Euclid's axioms. Starting with his definition, Euclid assumed certain properties which were not to be proved, and these assumptions were actually obvious, universal truths. Okay, so he divided them into two types, axioms and postulates. He used the term postulate for the assumption that were specific to geometry, and common notion often called axioms were assumptions used throughout mathematics. Okay, not specifically linked to geometry. So he defined postulate and axiom. What were his axioms? Things which are equal to the same thing are equal to one another. If equal are divided to equals, the wholes are equal. If equal are subtracted from equal, the remainders are equal. Things which coincide with one another are equal to one another. So these are four things which depends on equal whole. Okay, the whole is greater than a part, obviously. So what after my reading the line, what you're thinking, it's obvious. It's axiom. Okay. Now this is a way to learn. I'm just teaching you, I'm just reading the line, and whatever line you think, obviously, that's axiom. Exactly. Things which are double of the same thing are equal to one another. Things which are half of the same thing are equal to each other. So, I hope this axioms are clear. This common notion refer to magnitudes of some kind. The first common notion should be applied to plane figures. Magnitude of a same kind can be compared, added, but magnitude of different kind cannot be compared. Right? The fourth axiom seems to say that if two things are identical, then they are equal. In other words, everything equals itself. It is justification of the principle of superposition. Axiom 5 gives us the definition of greater. Okay. Now, what were his postulate? Postulate 1. A straight line may be drawn from one point to another. So a point P is given to you, another point Q, you can draw a straight line from one point to another. Okay. What is axiom 5.1? Given two distinct points, there is a unique line that passes through them. Okay. I have told you in previous classes also, if only one point is given, there are infinitely many number of lines that are passing through that point. But if 2 points specifically are given, there's only one possible line that can go through that. Okay. See, it's showing the same thing which I just told. A point consists of infinitely many points, but a 2 point in common has only one. Okay, so see, P and Q have many lines passing through them, but both included are postulate 1. We have completed. Now postulate 2. A terminated line can be produced indefinitely. What is terminated? According to the present day terms, we can see a line segment can be extended on either side to form a line. Okay, so A and B are the endpoints, but we can extend it to any further. So indefinitely we can extend. A straight line, first postulate, is drawn from one point to another. A terminated line can be produced definitely. We have covered. Now third postulate, a circle can be drawn with any center. Obviously, if a center and a radius is given to you, you will first mark the center on a plane, and then according to the radius, you will draw a circle. Postulate 4, all right angles are equal to one another. Now, moving towards further Euclid's axioms and postulate. Okay. What's postulate 5 says? If a straight line falling on two straight lines make an interior angle on the same side of it taken together less than two right angles, then the two straight line, if produced indefinitely, meet on that side on which the sum of angle is less than two right angles. Just let me tell you this whole axiom postulate with an example. Just see, A, B and CD are two lines, and a transversal to this line or a line intersecting both the lines is PQ. 1 and 2 also other side angles will be formed, right? And we know that the sum of angles on the same side, if it is less than 2 right angle, that is 180 degree. So on the side where it is less than 180 degree or 2 right angle, they will meet. Okay, not on the other side. If extended, obviously. So that's what the postulate says. Now, postulate 5 is far more complex than any other postulate. Okay, postulate 1 through 4 are so simple and obvious that it is taken as self-evident. However, it is not possible to prove them. So this statement are accepted without any proof. But 5 is a little complex. Okay, but 1 to 4, I hope you have understood very well. Now, nowadays postulate and axioms are termed as used interchangeably in the same sense. Postulate is actually a verb. When we say let us postulate, we mean let us make some statement based on the observation on the phenomena in the universe. Okay. Its truth and validity is checked afterwards. If it is true, then it is accepted as a postulate. So, what can be proved is postulate, but what we have to accept it as universal truth is axiom. Okay, according to Euclid. A system of axiom is called consistent. If it is impossible to deduce from this axiom a statement that contradicts any axiom and previously proved statement. So, when any system of axioms is given, it needs to be ensured that the system is consistent. Okay. After Euclid stated his postulate and axioms, he used them to prove other results. And then using this riddle, he proved some other riddles by applying deductive rules. And the statement that were proved are called propositions or theorems. And Euclid deduced 465 propositions in a logical chain using his axioms, postulate, definition, theorems proved earlier in the chain. Okay, now, so you can imagine how many postulates, how many axioms would have been used in this long chain of 465. If, okay, we'll just take an example. If A and B, C are 3 points on a line, B lies between A and C, then prove that AB plus BC is equal to AC. Now just think how we'll prove. Obviously, no, this is very obvious question, but you need to prove it according to Euclid's axiom or postulate. So just do it. So, according to Euclid, okay, just think of an axiom which satisfies the condition. Okay, I have remembered the axioms. You can just learn and then it will be easy for you to solve such question. Axiom number 4 of Euclid states that intersecting or coinciding. Coinciding would be a term. Are equal. Statement is not same. You can write the exact statement. I'm just writing it literally. Okay, the meaning is same. So we can see that AC. Okay, line AC. Just don't think of B. Okay, so line AC coincides with AB plus BC. So if two things are coinciding, that means they are equal. As simple as that. So AC will be equal to AB plus BC. I hope the question is clear to you. Okay. So we need to actually use the prove that equilateral triangle can be constructed from any given line segment. Okay, just think of an axiom again. In order to prove this question, we first need to use certain geometry. Okay, so just come with me, take pen and paper and draw a line segment of any line. It's your choice, A and B suppose. Okay, now just take your compass and take an arc and cut it from B and the same radius, don't change the radius, cut it from A. And the point at which they intersect, name it C, and then join AC2 and BC. Okay, so this is a construction for equilateral. Now, in order to prove that the drawn triangle is equilateral, we have to prove that AB is equal to AC and BC. So, from a Euclid's axiom, we know that two things, if equal to the same thing, they are equal to one another. Okay, so from this axiom, we can state that AB is equal to AC and BC. Since I have already told you, don't change the radius of the arc. So if the radius is same, so they are literally same to the same thing, hence they both are equal. I hope this is clear to you. Now, theorem 5.1. Two distinct lines cannot have more than one point in common. Here we are given two lines L and M. We need to prove that they do not have any point in common except one. For our time being, let us suppose that two lines intersect two distinct points P and Q. So we have two lines passing through two distinct points P and Q, which contradict Euclid's, but this contradicts the Euclid's postulate which says that two point has a unique line passing through it. Hence, so the assertion we started that two lines can be passed through two distinct points is wrong, and we have provided the conclusion, or we have drawn this conclusion of theorem 5.1 that two lines cannot have more than one point in. So this is how the theorems are proved using Euclid's axioms and postulates. I hope the lecture is clear to you. From the part 3, we'll be starting with equivalent versions of Euclid's fifth postulate. And from that on, we'll move it forward. So let's end the lecture for now and meet on the next part. Thank you so much.